The braid on the heat trace cable is an electrical shield. This electrical shield is not a ground wire and should not be connected to ground. Simply leave the electrical shield as is, without cutting or stripping it. To terminate the heat trace cable in a metal box, firstly remove the outer jacket of the heat trace cable for about 6 inches, exposing the black, white, and electrical shield. Secondly, crimp or solder a strain relief connector to the outer jacket of the cable. Thirdly, connect the black wire to the terminal labeled line hot on the thermostat. Fourthly, connect the white wire to the terminal labeled line neutral on the thermostat. Fifthly, leave the electrical shield disconnected. Sixthly, secure the cable to the knockout using a lock nut. Finally, seal the knockout with a weatherproof bushing. Do not splice the heat trace cable. Connect one end of the heat trace cable to the load hot and load neutral terminals on the thermostat. Connect the other end of the heat trace cable directly to the power source. Remember that heat trace cables typically draw a significant amount of current. Consult with an electrician to determine if the circuit can handle the load. Protect the cable from physical damage by securing it to the pipes or walls using cable clamps or ties. Regularly inspect the heat trace cable and connections for any damage. To reiterate the process, first identify the electrical shield, which is the braid on the outside of the cable. This shield serves to minimize electrical interference and should not be connected to the ground. Instead, leave it as it is, without any cutting or stripping. Next, focus on terminating the cable within the metal box. Begin by carefully removing approximately 6 inches of the outer jacket of the heat trace cable. This will expose the inner wires, typically the black hot, white neutral, and the electrical shield we previously discussed. To ensure a secure connection to the metal box, use a strain relief connector. Crimp or solder this connector to the outer jacket of the heat trace cable. This will prevent any pulling or tension on the wires inside the box. Now it's time to connect the wires to the line voltage thermostat. Connect the black wire, which is the hot wire, to the terminal on the thermostat that is labeled line hot. Similarly, connect the white wire, which is the neutral wire, to the terminal labeled line neutral. Remember to leave the electrical shield disconnected. It should not be connected to any terminals or grounded. To secure the cable to the knockout in the metal box, use a lock nut. This will prevent the cable from moving or being pulled out of the box. Finally, seal the knockout with a weatherproof bushing. This will protect the connection from moisture and other environmental factors. When wiring the line voltage thermostat, avoid splicing the heat trace cable. Instead, connect one end of the heat trace cable to the load hot and load neutral terminals on the thermostat. Connect the opposite end of the heat trace cable directly to the power source. Since heat trace cables can draw a significant amount of current, it's important to consult with an electrician to determine if the existing circuit can handle the added load. This is a critical step to prevent overloading the circuit and potentially causing a fire hazard. Protect the heat trace cable from physical damage by securing it to the pipes or walls using cable clamps or ties. This will prevent the cable from being damaged by impact or abrasion. Regularly inspect the heat trace cable and its connections for any signs of damage. This includes checking for cuts, abrasions, loose connections, or corrosion. If you find any damage, repair or replace the cable immediately. Before beginning any electrical work, always turn off the power to the circuit at the breaker panel. This will prevent electric shock. If you are not comfortable working with electricity, consult with a qualified electrician. Incorrect wiring can be dangerous and could result in fire or electric shock. Follow all local electrical codes and regulations. These codes are in place to ensure the safety of electrical installations. When selecting a heat trace cable, choose one that is appropriate for the application. Consider the pipe material, the ambient temperature, and the required freeze protection temperature. Use only approved connectors and fittings for heat trace cable. These connectors are designed to provide a secure and reliable connection. Do not overload the circuit with too many heat trace cables. This can cause the circuit breaker to trip or the wiring to overheat. Ensure that the heat trace cable is properly grounded. This will help to protect against electric shock. Test the heat trace cable after installation to ensure that it is working properly. Use a multimeter to check the voltage and current. Keep the heat trace cable clean and free of debris. This will help to prevent overheating. Replace the heat trace cable if it is damaged or worn. A damaged cable can be a fire hazard. When installing heat trace cable on plastic pipes, use a heat conductive tape to improve heat transfer. This will help to prevent the pipes from freezing. Do not install heat trace cable in areas where it could be exposed to flammable materials. This could create a fire hazard. Ensure that the heat trace cable is properly insulated. This will help to prevent energy loss. When using a thermostat to control the heat trace cable, set the thermostat to the desired temperature. This will help to conserve energy. Regularly check the thermostat to ensure that it is working properly. A malfunctioning thermostat could cause the pipes to freeze or the heat trace cable to overheat. When using a timer to control the heat trace cable, set the timer to turn on the cable during the coldest hours of the day. This will help to conserve energy. Regularly check the timer to ensure that it is working properly. A malfunctioning timer could cause the pipes to freeze or the heat trace cable to overheat. When installing heat trace cable in a wet location, use a waterproof connector. This will help to prevent water from entering the electrical system. When installing heat trace cable in a hazardous location, use an explosion-proof connector. This will help to prevent an explosion. When installing heat trace cable on a metal pipe, use a grounding clamp to connect the electrical shield to the pipe. This will help to prevent electric shock. Consult with the qualified electrician for any questions or concerns about heat trace cable installation. They can provide guidance on proper installation techniques and safety precautions. Always prioritize safety when working with electricity. Take the necessary precautions to protect yourself from electric shock and fire hazards. Remember to double-check all connections before energizing the circuit. A loose connection can cause arcing and overheating. Keep a record of all heat trace cable installations. This will help with future maintenance and repairs. Consider using a heat trace cable with a self-regulating feature. This type of cable automatically adjusts its heat output based on the ambient temperature. This can help to conserve energy and prevent overheating. Use a cable tie to secure the heat trace cable to the pipe every 12 inches or so. This will help to keep the cable in place and prevent it from being damaged. Do not allow the heat trace cable to cross over itself. This can cause overheating. Do not install heat trace cable on pipes that are already insulated. The insulation will trap the heat and could cause the cable to overheat. Use a heat sink compound between the heat trace cable and the pipe to improve heat transfer. This will help to prevent the pipe from freezing. When installing heat trace cable in a corrosive environment, use a corrosion-resistant cable. This will help to prevent the cable from being damaged by the corrosive elements. Use a UV-resistant cable when installing heat trace cable in direct sunlight. This will help to prevent the cable from being damaged by the sun's rays. Before working on any electrical equipment, make sure to de-energize the circuit and verify that the power is off using a voltage tester. Wear appropriate personal protective equipment (PPE) such as safety glasses and gloves when working with electricity. Work in a well-lit and dry environment. Avoid working in damp or wet conditions, as this increases the risk of electric shock. Keep your work area clean and organized to prevent accidents. Avoid distractions while working with electricity. Focus on the task at hand and pay attention to what you are doing. If you are unsure about any aspect of the heat trace cable installation, consult with a qualified electrician. Do not attempt to perform electrical work that you are not comfortable with. Always follow the manufacturer's instructions when installing heat trace cable. This will help to ensure that the cable is installed correctly and safely. Regularly inspect the heat trace cable for any signs of wear or damage. Replace the cable if it is damaged. If you experience any problems with the heat trace cable, contact a qualified electrician for assistance. Do not attempt to repair the cable yourself. Educate yourself about the dangers of electricity and the safety precautions that should be taken. This will help you to protect yourself from electric shock and fire hazards. Heat trace cables are an effective way to prevent pipes from freezing, but it is important to install them correctly and safely. By following these guidelines, you can ensure that your heat trace cable system is working properly and protecting your pipes from damage. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns. These cables should also have a ground fault protection. These cables should also not be installed in areas where they are exposed to physical damage, chemical damage, and excessive heat. The National Electrical Code, NEC, Article 427 covers the installation of electric heat tracing and heating systems for pipelines and vessels. Article 427.10 provides requirements for the grounding of heat tracing systems. It states that all exposed metal parts of electric heat tracing systems that are likely to become energized shall be grounded. This includes the metal braid of the heat tracing cable, metal enclosures, and metal fittings. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, which will cause the overcurrent protective device, such as a circuit breaker or fuse, to trip and energize the circuit. This helps to protect against electric shock hazards and prevents damage to equipment. There are several methods that can be used to ground electric heat tracing systems. One method is to connect the metal braid of the heat tracing cable to a grounding electrode conductor, which is then connected to a grounding electrode, such as a ground rod or a metal water pipe. Another method is to connect the metal braid of the heat tracing cable to the metal enclosure of the heat tracing system, which is then grounded. It is important to follow the NEC and the manufacturer's instructions when grounding electric heat tracing systems. Improper grounding can create a safety hazard and can damage equipment.